Okay, welcome everybody. This is HTTPS in ASP.NET Core in Linux and Docker Linux containers. We're going to dig into certificates and how we use certificates inside of Docker to produce similar debugging results, which is really cool. So here's the part where I tell you, I'm definitely going to post my slides on my blog tonight. You're going to check tomorrow, next week, next month. In about 3 months, you're going to get tired of waiting. You're going to email me. I'm going to reply in 6 months and say, no, I'm definitely going to post them on my blog tonight. And I'll never post them at all. Which is why if you go to robrich.org right now, you can click on presentations. You can scroll down to this talk right here, and you can look at the slides or the code right now. They are online right now at robrich.org. Achievement unlocked. So while you're here, click out here on About Me, and you'll learn a little bit about me. I'm a Microsoft MVP, a friend of Redgate. Some of the other things that I've done, AZ GiveCamp is particularly exciting. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver those completed projects back to the charities. It is really, really fun. Sleep is optional, caffeine provided. If you're in Arizona, in Phoenix, come look us up because that is really, really cool. One of the things I'm particularly proud of is that I replied to a .NET Rocks episode. They read my reply on the air. They sent me a mug. Woohoo! And if you'd like no, I'm just kidding. So that's a little bit about me. But we're here to learn about HTTPS. We talked about this guy. HTTPS. So here's kind of where we're going to go. Why do we have certificates? What's in a certificate? How does ASP.NET do this in the box? And what can we do about that? How do we do that in Docker? And how do we fix it? And then net result, you give me 5 stars on Yelp. Woohoo! Yeah, so that's going to be fun. So why certificates? Well, this is Troy Hunt. He's the guy on the left. He came to the United States government and tried to explain to them how cybersecurity works. I love it. His Aussie socks, those are just really cool. So, ultimately, government people are what they are, so they actually had to go interview Facebook and all these other people to try and figure out if their pics on their phone got sent to their wives. I'm not sure why that was a relevant question, but yeah. So why certificates? If your answer is because Troy told me so, that is a perfectly legitimate answer, and I completely applaud that. Yes, use certificates because Troy told me so. So ultimately, digging it a little bit deeper than because Troy Hunt told me to, why would I use certificates? Well, certificates usually serve 2 main purposes. The first one, I will encrypt the traffic over the wire so that nobody can snoop on it and see what I'm doing. And the second is so that I can verify that the server is who I expect it to be. Now that's the client validating that the server is who we expect it to be. We could use certificates the other way. We could have client certificates so that the server could validate that the client is who they say they are. But client certificates are hard, so we generally don't. We generally use session cookies instead. So as I first connect to the service, I'll authenticate to them. They'll create a session cookie. They'll put that on my machine. And that's how the server validates the client because I pass them back the session cookie next time I make a request. How does the client validate it's the server that I'm talking to? Well, that's certificates. And so those are the 2 things. We encrypt the message, and we validate the message. So why is this important? Well, here's Firesheep. Firesheep was a plugin for Firefox, and Firesheep would go to a particular website and go steal that session cookie. So I have here on the left a list of session cookies that I found in that coffee shop. And now I just click on whatever persona I want to be, and it uses that session cookie to connect to the website. So I just pick who I want to be. Because I'm passing in the session cookie, then the server says, yeah, here's your Facebook page. Why did that happen? Because Facebook was using HTTP instead of HTTPS. So how do we block this attack? Well, use HTTPS. Now my session cookie is no longer sent through the air, and ultimately we can't get to where we need to go. Or hackers can't get my data in the middle. Another great example is a pineapple. This device, this little Wi-Fi device, will just listen to network traffic as I broadcast out saying, hey, is my Wi-Fi network available? You know how you get home and your phone automatically notices that you've gotten home and connects to your Wi-Fi? It's broadcasting looking for that Wi-Fi signal. So the pineapple just says, yeah, I'm that. So of course I'm going to connect, I'm going to pass in my Wi-Fi credentials, then I'm going to send all my web traffic through it. The pineapple then very carefully proxies that traffic off to the real server, and I'm none the wiser that they're now able to spy on my traffic. Well, why are they able to spy on my traffic? Because I'm connecting to websites with HTTP instead of HTTPS. So we thwart this attack by using certificates. Now we can't see that traffic in transit. So let's take this example. We create these tunnels, these HTTPS tunnels, so that we encrypt all of our traffic from here to there. Now that encryption process is really elegant, and it makes sure that my traffic can't be intercepted in the middle. So let's imagine that we have Alice here, and Alice is connecting to bob.com. And bob.com is using a TLS certificate, so HTTPS works successfully and all is good. All of the traffic is encrypted, and ultimately we can't see what's going on in their communication. Now let's imagine that we have someone, let's call him Jerry. So Jerry comes in here in the middle, and Jerry's going to try and spy on the traffic. Well, Jerry can't see anything, right? Because it's HTTPS. Well, Jerry's going to do something really interesting. Jerry's going to create an HTTPS certificate as well. So Alice connects to Jerry. Jerry proxies the traffic back to bob.com. Bob.com hands it a certificate. Jerry sends a new certificate back to Alice, and Alice has an encrypted connection to something, and Alice believes all is well. If we're only using HTTPS for encryption, then this is completely possible. I put a certificate in both places, and I can attack any site that I need to. So ultimately, it's not just about encryption. It is also about validating that that server is who I say that server is. So in this case, I don't want to talk to Jerry. I want to talk to the website. So how do we validate the authenticity of a website? Well, ultimately, we look for this. We've taught our users that they need to find that lock in the top left corner of their address bar. And each browser presents it in a little bit different way. But ultimately, I'm looking for that lock or that green bar or that thing that says that that site is who I expect them to be. And so ultimately, I get to a page like this, and now we need to teach users that you don't just click Advanced and click Proceed. That's a certificate fail. I love bad.com, badcertificate.com, because it's able to highlight these kind of errors in really interesting ways. So we're still kind of trying to teach them not to do this, proceed anyway thing. Well, your certificate's expired. Well, temporarily, can you just click Proceed? But never ever do that again, except for every time I tell you to do that. That's what we're kind of training our users to do is, you look for the lock except for when you don't. So a moment about DV and EV certificates, domain validated versus extended validated certificates. Domain validated certificates tell me that that server is responsible for that domain. And that's all it says is that, if I were to reach out to that domain, I'm reaching out to the correct server. Extended validated certificates take it a step further and say that server is part of this organization. So to get an extended validation certificate, they'll call the phone number on their website, they'll talk to executives, and they'll validate that that organization is who they say they are. And ultimately then, we either get a kind of nice green lock or we get the big green bar. And that's interesting, but ultimately our users are like, well, is it this or is it not this? Do I have to click proceed anyway? So, the industry kind of went, domain validated, extended validated, I don't care. I just don't want this. So, browser certificates. If I come up here, I see that this site is trusted. It has a lock here in the corner, and I can click on that and it'll pop up this box and it'll tell me about the certificate. So here in this certificate dialog, and each operating system and browser is ever so slightly different, but it'll tell me that here the certificate was valid from January 7th, 2019 to July 17th, 2019. It will tell me a little bit more about that certificate. Here's the version. The signature algorithm, SHA-256 is a great one. Valid from and valid to, which I'm not sure why Microsoft calls it that. Everyone else calls it not before and not after. But there's the dates. Here's the domains and other details that it works for. So this domain is sni147517.cloudflaressl.com. So yeah, I proxy my site through Cloudflare. Some public key details. Here's subject alternate names. And subject alternate names is really interesting because this is the other domains that are also supported on the same certificate. So if this certificate came back from one of these other domains, it would still be valid. So there's a few here. Cloudflare is wonderful at proxying lots of things, but there's my site, robrich.org, and now this certificate is trusted. Well, why is it trusted? Well, one of the other things that we have in here is this thumbprint, and that's kind of the serial number for this certificate, or the unique identifier of this certificate. Yeah, there's a certificate serial number property, but we use thumbprint to kind of reference that. There's that thumbprint, that serial number. If I have that serial number, then I know that I have that certificate. So we have then a trust chain. Why is this one green? Well, this certificate was signed by this certificate, and I can click on this one and click View Certificate and pull up similar details for that certificate. And that one was signed by this certificate, and that one was signed by this certificate, and ultimately then I get to this certificate, and now I'll come into Manage User Certificates or Manage Computer Certificates. Those assigned to my local machine or those assigned to me personally. So I've already pulled those up. Here's the user certificates and the computer certificates. I've popped open the Trusted Root Certificate Store. And here in the Trusted Root Certificate Store, I can kind of cruise through the certificates that have been pre-installed on my machine. And Windows Update gets these into place. So as Windows Update goes, it will give me new root certificates. And so ultimately, that certificate here at the top of the chain was pre-installed on my machine in here. I trust this certificate signed this certificate, which signed this certificate, and ultimately signed this certificate, and therefore I will go green for this certificate. So we looked at browser certificates and we looked at certificate stores. That's really interesting. We saw some of the properties associated with that. As you pull up these slides later on robrich.org, that'll be really helpful to see what we demoed in the previous slide. We looked through the subject name, the domain, and the subject alternate names, the other domains, and in particular, the thumbprint and the trust chain. We walked that trust chain to see that I pre-trusted this certificate that was the root of the certificate that ultimately served me, and that's why the certificate is green. So what can go wrong here? Well, probably the most likely thing is that certificate expired. When I get to that not after date and I'm past that, well, yeah, I'm going to get that gray screen where I have to hit proceed because that certificate expired. It'd be nice to kind of keep track of that and know when I need to renew that. Do I have a calendar entry on my calendar to make me go renew that certificate? Well, what else can go wrong? Well, we could use an insecure algorithm. A year or two or three ago, we all upgraded from SHA-1 to SHA-256 because SHA-1 was no longer considered a secure cryptographic algorithm. The big thing that goes wrong, and the thing we'll focus on here, is the trust chain. And we saw where we accidentally connected to Jerry instead of connecting to the website that we wanted to. And that ultimately didn't yield us a great experience. I love bad SSL right here. This is a link that will pop open this site. Bad SSL is a site that allows us to construct various bad certificate conditions. So for example, if I want to hit an expired certificate and see what happens, here's that thing. It says error cert date invalid. And I could click proceed and dig into how that works. But I just got a bad certificate associated with this experience just by clicking in through badssl.com. So as you're testing your site to make sure that it can do interesting things, that can be a great resource for finding broken trust chains, finding expired or invalid certificates, and doing all kinds of other things. Okay, so we looked at certificate stores on Windows. We have Cert Manager, both the user side and the computer side, that allows us to do things. Firefox takes it a little bit differently. Firefox doesn't use that store. Rather, they have their own. If I come in here to Options, and I view certificates, here are the certificates that they've pre-installed, rather than using the Windows Trust Store. Why do they have their own? So that's interesting. So on Windows, we have this central store. On Linux, I love this comment on the ASP.NET GitHub post. They filed an issue, and the answer was, trusting the certificate is only available on Windows and Mac OS because there is no standard way of trusting the certificate on Linux. Well, kind of. If you're on this one, you can trust it this way, and if you're on this one, you can trust it this way. Here are all the places where they keep that master list of certificates that they trust. But, I don't want to care about this list. So, of course, there's a bunch of programs that ignore that list completely. Firefox, Chrome on Linux doesn't use that list. They have their own. Apache, Java, Kestrel, the built-in ASP.NET web server, doesn't use the trust store. They use a certificate placed somewhere else. So on Linux, it's kind of this free-for-all. As we get into Docker, we're going to kind of fall into that, where there isn't a standard trust store that we need to play into. So in production, how do I do production certificates? I want that trust chain. I want to be a certificate that I bought from a valid place or that I grabbed from a trusted spot, so that then all of my users have pre-installed that trust chain and I'll get a green certificate. So step one, use Let's Encrypt. Let's Encrypt is really elegant for this. What if I don't want to use Let's Encrypt? Well, you start off by buying a certificate, and of course then you go looking for the download button, and they say there isn't a download button. So I go create a key. I use that to create a CSR. I upload the CSR to their site. They use that to sign the certificate in interesting ways. I download that certificate. I go try and install it into my web server, and oh crap, I downloaded the wrong certificate. So now I go back to the site. Do I need to re-upload the CSR? Do I need to create a new CSR? I eventually get the right certificate. I install it on my web server, and ultimately it doesn't work. And so then step 9, I use Let's Encrypt. So Let's Encrypt. Let's Encrypt is really, really cool because they offer this free certificate service. You put a daemon on your website, and you connect to their certificate store, and you make a request. They make a request back to validate that you own that domain. Ultimately, they issue the certificate, and that daemon ends up installing that certificate on your web server. No fuss, happens automatically. So they have really short-lived certificates that are able to do that process whenever they need to keep your certificate up to date. It is really, really cool. So in production, buy a certificate or use Let's Encrypt. Outside of production, well, now what? Here on the Let's Encrypt docs, they talk about what to do in production or outside of production. So one of the cool things that they do is validate that you own the domain. Nobody can own localhost, so they can't issue a certificate for localhost. They have to make that inbound request into your system. So you don't have a public, if you don't have a publicly accessible IP, they can't issue a certificate for that domain. So in development and testing, yeah, we can't use Let's Encrypt. That's a bummer. And ultimately, what they invite us to do is to use OpenSSL to go create a self-signed certificate. Yeah. Okay, so in development and testing, what can we do? Well, what's really cool, because we're in this ASP.NET ecosystem, we have this really cool development experience kind of baked in. Let's look at that. I have Visual Studio 2017 here. I just went File New Project. I tweaked it a smidge, but in this case, it's the standard stuff. I'll set this as my startup project. And because we want to use Kestrel, not IIS Express, I'm going to come in here to the dropdown, and I'm going to choose my project, as opposed to IIS Express. I don't want the IIS Express details in this, because we won't have IIS Express when we get to Docker. So I'm going to fire up this solution. I'll actually set multiple startup projects here. And let's fire up this site. There's Kestrel firing up. It's going to launch a browser. Here's my browser. And I have a trusted certificate. I have a green lock. Well, why is this lock green? If I click here on View Certificate, here's my certificate. It's issued to localhost. I'm browsing to localhost. That's great. It's not expired. I can come look in here at the details and see that it is the ASP.NET Development Certificate. I can look at this thumbprint. Ultimately, that certificate is here in my certificate store. Not that one, this one. Here's the localhost certificate, and that one has that same thumbprint, FD0815. Here's the certificate that I trust. Here's the certificate that I got from the website, FD0815. It is a self-signed certificate, but I trust that certificate. Therefore, I get HTTPS in the box from Visual Studio. Well, that's really cool. I also went to HTTP localhost 5000. It did the automatic redirect. That's really cool. Here in Visual Studio, let's go looking for, where's the plumbing that did that? Well, here in program.cs, we don't see anything different from an HTTP to an HTTPS project, so it's not here. Here in startup.cs, we'll see a little bit of a distraction. There's things in here about use HSTS, certificate pinning. That's really elegant, because then they won't have to keep downloading the certificate. And I've told them to only use HTTPS going forward for this site. We only do that in production because we don't want to pin our development machine to a fake certificate. That would be bad. Undoing that is a really interesting Google search, by the way. We see this use HTTPS redirection. That's interesting, but those are the only clues here that we have HTTPS going on. Well, where is the HTTPS magic? Is it in app settings? No, app settings is pretty bland. Here inside launch settings, inside the property folder, we see that IIS Express content. We can just delete that. We don't need that for this demo. we want to use Kestrel. So going forward, we have just that one thing in the list, and we can see a little bit of a clue. We now have two URLs here. The application URL is HTTPS localhost 5001 and HTTP localhost 5000. I've told it to launch on two URLs instead of just one. And one of them is HTTPS, but I haven't specified a certificate. I haven't done any of the rest of that. Well, that's really cool. Obligatory kittens. So out of the box, we have this great HTTPS development story from Visual Studio. I have certificates that I've pre-trusted. I can hit that certificate and I can do really elegant things. It's going to do automatic HTTPS redirection. In production, I'll have certificate pinning. That's great. So ultimately, how does this happen? In program.cs, we had webhost.create default web builder. ASP.NET is open source, so let's go looking at create default web builder. Well, that's going to go create the builder, and it goes and does a bunch of stuff about is it development, go grab the user secrets. That's really cool. Grab environment variables, configure logging. Ooh, configure web defaults. That's pretty cool. Configure web defaults. So configure web defaults, and this is a link that'll pop us open to this page. Configure web defaults says, hey, builder.use Kestrel. Okay, so it's going to go grab that Kestrel section from the web config. We didn't have a Kestrel section in our web config, so digging a little bit deeper, there's a whole lot more calls that happen, and then ultimately we go try to find that developer certificate file. Try get certificate path. So it's going to look inside app data. It's going to look inside the home environment variable. If either of those are set, it's going to go look for a specific path inside there. And it's ultimately going to look for appname.pfx. Well, I don't have an appname.pfx, but let's keep digging in there. Ultimately, it's going to look for cn equals localhost. So that's here. Is it a development certificate? Well, it is if the CN is localhost. If the domain is specifically for localhost and only localhost, is that the development certificate? Digging in a bit further, it's like, well, how does it know how to use this as opposed to whatever's passed to it? Well, if it has some addresses, then it'll use the addresses. If it doesn't have the addresses, then it will use this default address strategy, which means go figure it out. If I didn't have those launch options.json, then it would dig in here. And ultimately, there's a constant way, way deep in that call stack which says localhost 5000. That's how it knows how to launch on localhost 5000. Go grab that development certificate and ultimately launch Kestrel to do interesting things. And then what's really cool is it also says now listening on, and it'll spit out those ports. Well, how does it get these ports? It's looping through addresses that it gets here from the server features, the server address features, and then it's just looping on those, splitting on semicolon. So I passed it that list of URLs to launch, it split that on semicolon and did some interesting things, and then ultimately console logged those to say, I'm now launching on these two ports. I love that ASP.NET is open source now. So that's kind of how we get from this program that says nothing about a certificate to automatically getting this certificate out of the box. That's really cool. And all that was built in as I installed Visual Studio, it fired it up. If I'm not using Visual Studio, as I install the .NET SDK on Linux, I'll get my certificate dumped in this directory, .net/corefx/ blah, 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 startup.pfx. And it's a PFX file. It's not a PEMSUR file, even though it's on Linux. It's a PFX file. Bummer. It's not in that Linux trust store, They just kind of stuck it in this .NET directory. Okay, that's interesting. So how do I make this certificate? Well, I can, from the command line, I can say .NET dev certs HTTPS -- trust, and it'll take that certificate and it'll put it in the trust store for my OS. So I can find this program here inside C program files, .NET SDK 2.2, whatever version I'm on, .NET tools, .NET dev. And so here in that spot, here is that .NET dev certs DLL. But ASP.NET is open source, so let's go look at the source for that. Here's program.cs, and program.cs will go grab .NET dev certs HTTPS, and then go grab the command lines. As I say trust, it'll then call into this method, create ASP.NET development certificate. And ultimately, what's wonderful and annoying is this trust certificate method down at the bottom. If the OS platform is Windows, then trust it this way. If the OS platform is Mac, trust it this way. We're on Linux. Sorry, we're not going to trust on Linux. They just punted. They didn't try and figure out, this distro does it this way and that distro does it that way. They just say, nope, we're not going to trust the certificate on Linux. So if you say -- trust on Linux, it will not do that. And thus it buries it in its directory instead. Okay, so let's dig into how we do this in Docker. Well, in this application, we did some interesting things that I just kind of glossed over. I've launched both projects again. Here's that now listening on HTTPS 5001 and now listening on HTTP 5000. Here on the home page, I'm going to go grab the list of addresses that I'm bound to, which is pretty cool. I just kind of reached into those environment variables and I did that. Let's look at those environment variables. Here in the home controller, I just reach out into this gently get endpoint addresses service or method. That looks pretty familiar. I go get the iServer address features, I go loop through those, split by semicolon, and I go spit out those URLs. Well, I also did something else kind of interesting here. I want to get at the certificate. I want to get at that thumbprint. I want to get at the trust chain. I want to see, is that certificate, is the development certificate loaded? In this case, it is. And what are those details about that certificate? So, of course, I head off to GitHub and I go look at this comment where David Fowler very specifically says, no, don't do it this way. So here inside Kestrel, inside the options, is this list of things. So yeah, of course, David Fowler said, definitely don't do what we're about to do. So we're going to go grab that the listen options. We're going to reflect into that listen options property because it's private. Let's grab those listen options, and we'll reflect out on those listen options the HTTPS details, including the certificate, or the HTTP details, the address and port, so that we can show them nicely on the screen. And while we're there, let's reflect a couple more interesting certificate details. So this page is trusted. This page is trusted because the certificate here this FD0815 certificate is in our trust chain. It's a trusted certificate. That's why that works. Here's that FD0815 certificate. So the other interesting thing that we're going to do here in this is call an API. So here in our home controller, we'll go create a URL, and I swap this out with badssl.com to kind of see that experience, but then we'll call this service. Now this service is going to do something interesting. Go create that HTTP client handler, get the string get async that URL, grab the status code, grab the response, deserialize it into JSON, and ultimately return that. That URL, that values controller, is back here that's doing something really similar that is just, I don't know, going and hacking the endpoints and grabbing the certificates. So ultimately, it'll be able to return the certificates that the server is hosting through that URL. It's not returning the certificate itself, but rather just unique list of thumbprints. So the other interesting thing that we're doing here is we're going to go grab that certificate in the middle of doing that TLS handshake. So step one, when we Google for anything and land on Stack Overflow about what's wrong with my HTTPS certificate, is that thing about how to turn off certificate validation. Remember Bob accidentally connecting to Jerry? Well, yeah, if I go to do this server certificate custom validation callback and I return true here, then it will always accept it whether that certificate is invalid or not. In this case, we're very specifically not doing that. We're going to look at, does the error match none? If it's not failing, then it is valid, and we'll continue on. And we'll just kind of grab the other details in here. So how do we do this in Docker? Well, while we're here, here's that site, but inside of a Docker file. So I've hacked this Docker file a smidge to be able to get at all of the details that we need. If I had just said add Docker support, it would have had a little bit different experience. But I really wanted this ASP.NET Core URLs in here. So I'm specifically building in debug. I'm specifically starting in development mode so I don't trigger that HSTS certificate. And then ultimately, I'm launching there. So let's kick this off in Docker. Docker run all of the things. I've built that container previously. We failed. The development certificate is installed as the SDK is installed. Here inside VS Code, we're not using the SDK, we're using the runtime image. This runtime image doesn't have a development certificate in it. Therefore, there's no certificate for Kestrel defined. Therefore, starting the file doesn't work. So why does this work when I just say Docker compose up or push play inside Visual Studio when I add Docker support? Because we don't specify this URL here. And so it will happily launch in HTTP only mode. Have you ever deployed your site and you accidentally left that one HTTP reference? And of course, the browser is going to block it because the rest of the site is SSL, is TLS, and this one is not. When we develop in HTTP, we kind of lie to ourselves. Let's really push forward and see if we can develop in HTTPS. So let's leave that one there, and let's take another stab at this. So I know I need a certificate. So I'm doing the same thing up at the top. I'm just running .NET dev search HTTPS just to make sure that that certificate is there. It'll output whether it was there or whether it created it. That's kind of nice. And then here's the magic right here. I'm going to go grab the root.NET CoreFX cryptography, and it goes on for a while, that directory, and I'm going to copy it to the new containers root.NETFX CoreFX cryptography directory. Now I have that root certificate. Now I have that development certificate. So now when I launch, I'll be able to do really interesting things. The rest of this is identical. So let's come in here to this directory, Docker compose up. We're launching our server on localhost 5000 and HTTPS 5001. Our API is on 4000 and 4001. That's interesting. Let's go to localhost 5000. And we did get that redirection, but we got a certificate fail. Well, why did we get that certificate fail? Let's dig in here to view that certificate. Well, that development certificate thumbprint is E3D9E9FE. Now, our development certificate is different. This is for localhost, and it's valid, but I don't pre-trust this thumbprint. I pre-trust my development certificate thumbprint. This is Jerry jumping in the middle. Well, let's not use that development certificate. Let's instead, let me clear that data just to make sure that that is gone. Docker compose down. Let's look instead at this. So I start out by getting my local development certificate, and I'm going to use that same .NET Dev Certs program to export my certificate to localhost.pfx, and I need to set a password. Well, why do I need to set a password? ASP.NET's open source, so let's go look at the source to ASP.NET here. When I go grab that URL, here's where it goes and looks for it, and it passes in password.hasValue. And on the other side to password.hasValue is where it takes in the include private key. So if I pass in a password, it will export the private key. And if I don't pass in a password, it will not export the private key, which means the server can't sign requests. Why do I need a password? Because they were lazy? Or were they security conscious? You know, either way, fine. I need to set a password. So I get that localhost.pfx, and I'm just going to set it inside this directory. Here's our directory. And I just put it right here for convenience, my localhost pfx. I'm not going to check this in because it's the certificate that I trust, but I now have this certificate. So inside of our Docker file, let's go copy that certificate into place in our running container. Now it has a certificate. Well, kind of. It has a certificate, but the certificate has a password, and the development certificate doesn't. So I need to do some OpenSSL magic to convert it to a PEM and a key, convert it back into a PFX, very specifically set a blank password here, and now I have localhost nopass.pfx. It is my local trusted certificate with the private key inside of it, but without a password, that I'm just going to copy into that magic directory where Kestrel's going to look for it. That is great. For the sake of time, let's skip running that demo and dig straight into this next one. So I've got that certificate in place, but as I call into the API, I notice that that certificate isn't trusted. So I'm still not, it's trusted by my local machine, but it's not trusted by the web server. So when I call the API still fails. So let's do a little bit more magic. I'm going to convert it into a PEM and a key, and then I'm going to convert it back into a PFX with no password again. I'm going to copy that localhost no pass.pfx into the proper spot, but because Linux generally uses pem and key, I'm going to copy that pem and key into the right spot, and then ultimately run the trust the certificate piece appropriate to my Linux distribution. And in this case, we're using Alpine, and so Alpine uses certificates this way. So I'm going to do this all in one step, so it'll be one layer. I will APK update, add the CA certificates, remove that APK cache, update the CA certificate so that trusts the certificate in the certificate store. I'll just go list the directory to validate that that worked correctly, and then I'll echo that it did, ultimately then firing up the thing. So let's go in there to step 5 and let's go run that one. Docker compose up. It starts, and it starts with the development certificate that's already trusted on my machine. And so I'm going to go to localhost 5000, and now I'll go into the hack, and the hack does say that I've got that FD0815 certificate. That's the certificate it loaded. I'm going to go make an API call, and the API call is going to fail. Well, that development certificate is very specifically bound to the domain localhost. And this is making a call out to HTTPS API :4001, not localhost. So that's why that trust chain failed. It's still the development certificate. I've installed it in both places, but I'm using a different URL. Well, now why did it fail here? Because the Docker host that I'm using is not actually on localhost, it's on Minikube. So I got a name fail here too. So that certificate, we can go look at that certificate. It's issued to localhost. I have the right thumbprint, but the domain didn't match, and therefore I get this remote name mismatch. Okay, let's clean that one out. Docker compose down. Okay, so for step 6, I'd like to do some OpenSSL magic. I'd like to, go grab that certificate and transform it into all the things. I'm going to create a self-signed certificate, but it's going to include Minikube, and it's going to include API. And maybe I can do this really cool thing where I have a Docker container that actually generates the root certificate, and I'll map a volume so that then maybe it'll just show up magically on my drive. And you ever get most of the way through an engineering problem and realize that that was a really, really dumb idea, and that was just overly complicated? Yeah, all of those OpenSSL commands are just scary. So, OpenSSL is wonderful, and I love it. But I reach for this all the time. I can never remember all those parameters. The most common OpenSSL commands, as I type OpenSSL commands, it is the first result on Google. I'm not sure if it's because I just kept clicking it, but it's wonderful. Here's how to generate a CSR. Here's how to convert a thing to this thing. Here's how to check to see if it worked. Here's how to convert it into different formats. All of that stuff in the previous Docker files, stick it in place. It is really cool. So OpenSSL is interesting, but that OpenSSL volume mapping solution was just too hard. So let's do something different. Well, there's this really cool program called Mixert, an open source program created by one of the engineers at Google who wanted to do exactly this. And so I download Mixert using whatever means that I need to. I can grab it through Homebrew, or I can go grab it in Linux from Linux brew after I've installed NSS tools or whatever I need to. I can grab a Windows binary from chocolatey, or I can just flip over here to the releases tab and go just download one. So I'll just go download that exe, and then it is just cake. I start off by saying mxcert install, and that will create my root certificate key and also the root certificate, and I'll use that to sign all of the other certificates. Now I have a trust chain. That kind of more represents what I'll see in production. Then I can run a second command, mxcert, and just pass it a list of domains and IP addresses. All of those OpenSSL commands just disappear. So all of that complexity is gone, and I now have a certificate that matches exactly what I want it to be. Okay, so I've downloaded mxcert right here. I've run it --install, or -install rather, and it spit out my root CA and root CA-pem, or -key, into this user app local data folder. Now for convenience, I'm going to copy it into my web directory just so I don't have to go reach for it in that local app data folder. I don't have the local app data environment variable set inside of Docker as I'm doing things. So yeah, that was annoying to copy through. But let's pop here into this Docker file. So it turns out that getting mxcert on Linux on Alpine is a little bit weird. So it's open source. I'm just going to go download it from GitHub. So I have this Golang Alpine container. I'm going to call this container cert. I'll go grab NSS tools. I need that to be able to get mxcert to run. I'll go grab OpenSSL just because, you know, I'm here. Go build mxcert from source, and I now have mxcert on /bin. So now that I have mxcert, let me go into that root directory, and I will copy my local machine's key and pem into place, and those become the trusted root certificates for this app. And then I'm going to say mxcert install, and mxcert key file, I'm going to output this as https-web.key, https-web.pem, so there's my key and my certificate. I'm going to then just list out all of the things that I need it to be. So I'm going to say Minikube. I'll also grab the IP address of Minikube. I'll grab localhost. I'll grab 127.0.0.1. I'll grab web because that's how Docker Compose is going to launch my app. And ultimately, then it'll spit out this key and pem. A little OpenSSL magic that I went and copied from the OpenSSL commands thing and set it in place so that I can get a PFX file. Well, why can't I just make a PFX file here? I love this part. Generating a P12 PKS file, also known as a PFX file, containing certificate and key for legacy applications. Score! Brand new platform built on legacy content. Oops. Okay, so I'm going to output it as pem and key, and then ultimately convert it into PFX. I'm doing my build in the normal way. It's still a debug build because this is not for production, this is for development. It's also going to copy in that root CA-key.pem, my private key for my certificate authority. I don't want that to leak. It's my local one, but still, that's not great practice. But we're not going to use this container for anything interesting. We're going to throw this away in a minute. Our whole goal is to do the build here. So it'll just dump out this debug build into the dist folder, and I'll copy that from the dist folder here into my app folder. Like I did before, setting the environment variables, but I'm going to do some other things too. I'm going to go reach into the cert container, and I'm going to grab from that cert container that mxcert bin, and I'm also going to grab the root ca.pem, the public key, not the private key, and I'm going to go grab that localhost -web.pfx and set it in my app directory. I could set it anywhere because that's the one that will actually run with my website, but putting it with the rest of my code seemed to make sense in this case. I'm going to set some environment variables, which is not that unlike the config I would want to set in the appsettings.json. But because I don't want to change my application at all for production use, I'll just set it as environment variables here. I'm going to go grab NSS tools to make mixert work. Mixert install, which will then trust this root certificate that I copied into place. I don't have the key, but I'm not issuing certificates here, so that's okay. Then I'm going to delete NSS tools. I don't need that in my production thing. And I'm doing this all as one layer, so it's not like, I'm adding it and then removing it in different layers. And then I'm going to remove that mixert bin as well. So I've kind of done all the things. I've trusted my certificate and put it in the spot where it's trusted. And now I also have my localhost or my https-web.pfx in my app folder, so that as I start up, now I have this trusted chain with the correct name. So I have a similar Docker file in the API project that does exactly the same thing, with the exception of it's going to have a different name here. It's going to have the API name instead of the web name. But otherwise, those are exactly the same. Docker compose up. My application is running. HTTP minikube 5000. I didn't clear the thing. I did not change my directory. Let's do that again. I didn't. Docker compose down. Thank you. So check out the wrong demo. Look, it's still broken. CD 7. Okay. Docker compose up. And I've built this Docker file previously as well. Okay, so my certificate, my website is running. http://minikube 5000. I automatically get redirected to HTTPS. Let's go look at that certificate. It's issued to, I have no idea what that is, and that's fine, because here in the subject alternate names is all of those things that I specified: minikube, localhost, web. Now what's interesting, this thumbprint isn't the thumbprint of the certificate that I trusted. Here's that certificate that I trusted. Here's my mixert certificate, and its thumbprint is BA39D. And this web certificate is E2E8F. So I should get a fail here, right? Well, yeah, I'm not trusting this certificate. Rather, this certificate was signed by that certificate. And that certificate is BA39D. That's the one that I've pre-trusted. And so I get a green lock. Well, let's go look at this again. Let's go hit that. We see our 5001 and 5000. Let's go try and get the details of that certificate. No, it's not a dev cert, but here's that certificate, E2E8F3. Now the magic sauce. Can I call an API from another microservice and have that trusted inside of Docker's local network? Yes, I can. I created that API certificate there, and it is trusted as well. Now, it's not the same certificate. This is F43792, but that certificate is trusted by this same root certificate. I've trusted this root certificate in my local machine. I've trusted it in each of my containers. And so I can make trusted connections to all of the places that I need to. This is really cool. I can use HTTPS inside of Docker and still start to experience the way my website should behave in production. In production, yes, use Let's Encrypt. Because we can't use it in because we can't use Let's Encrypt in development, let's instead use this mechanism for being able to sign interesting things. We walked through each of these demos where we did interesting things to try and build up the development certificate. We did a whole kind of interesting thing here on step 6 and ultimately abandoned it. But McCert is really cool at doing interesting things to be able to use development certificate straight away. As you pull these details, these slides from robrich.org, here's some other reference material if you want to dig in deeper. And that's what I've got. Thank you for coming. What questions? Yes. What if the API was only available inside the network? It would still work just fine. Because I have that trust chain between them, I can make those requests. I just happened to expose the API publicly just so that I could poke at it too. But if I flipped over to Kubernetes and made it a cluster IP rather than a publicly accessible API, that would be just fine as well. Thanks for coming.